We're going to be looking here at lesson 35. So in order to describe a chemical substance, you can draw a structural formula. This is like Lewis structures where you draw everything, draw the bonds. These take a while and can be difficult though. There's another type of formula called a molecular formula. What it does, it tells you what kind of atoms are involved, and it tells you how many atoms are involved, but it does not tell you the shape or location of the bonds, which makes them much more convenient than a structural formula. Okay, so that's a molecular formula. And then lastly, an empirical formula. This is actually a typo. An empirical formula, what these do, they tell what elements are present, but they give the simplest whole number ratio of atoms in the compound. So an example of doing a simplest whole number ratio would be if I had a classroom with say 5 boys and 10 girls, I could say I have a 1-to-2 ratio of boys to girls, right? So you can break something down in a ratio, and we can do that with these formulas. Look at this example. I'm trying to zoom in. Okay, it doesn't want me to zoom in. All right, let's just go there. Water. The molecular formula is H2O. Because you have 2 H's, 1 O, you cannot reduce that any further, so it has the same empirical formula. But then go to ethane. The molecular formula is C2H4. Both of those can be reduced by 2. So it's actually C1. You don't ever write a 1, so just CH2. You see that when you divide both those by 2. If chlorine is diatomic with Cl2, you can just reduce that into just Cl. So empirical is the reduced version of the molecular. Sometimes if the molecular is already simple, they're the same. So all of the following compounds, they have the empirical formula of CH2O. So look, CH2O, look at C2H4O2. You divide all those by 2, you're at CH2O. C3H6O3, divide all of those by 3, you're at CH2O. C4H8O4, divide them by 4, CH2O. Divide these by 5, CH2O. You see that? So that's all in a molecular formula. You reduce it and you make the empirical formula. So I want you first to do the first 4. So press pause, try the first 4, and then press play. Okay, do you think this is an empirical formula? The answer is no. That could both be reduced by 2. It should be CH2 would be the empirical of that. Number 2, is this reduced? Yes, absolutely. 1 and 1, you can't reduce that any further. Number 3, is this reduced? We have a 3, but only have 1. So no, it can't be reduced any further, so the answer is yes, it's empirical. So no, yes, yes. And then look at this one. Can these be reduced by anything? They can. So you could make this H1S1O2. So no, this is not an empirical formula. So it's no, yes, yes, no. Okay, now I want you to press pause. I want you to try to do 5 through 8, and then press play, and I will go over it, and you can make sure you're doing it right. Okay, so the molecular formula, C2H4O2, those can all be reduced by 2. So it'll be CH2O, CH2O. Number 6, N3O6, divide all those by 3, it'll be NO2, NO2. Number 7, H6S3O12. You can divide all of those by 3, which makes it H2SO4, H2SO4. And last but not least, H9N3, divide them by 3, and you'll have H3N. All right, so that's empirical molecular formulas. If you have any questions, please email me, and other than that, have a good day.